Hey everyone, so today I'm going to be going over the hardest challenge in the entire competition with only one solve, and it was solved after I added 2 extra hints. This is tunnel vision, so this is 80 points, and this is based off of the Pico CTF problem, tunnel vision. This was one of the hardest challenges in the Pico CTF 2021 series, and I took the inspiration and kind of just changed some stuff and put it in here, and it was the hardest challenge in the entire thing. So the prompt says, repair my image file please, and also get the flag while you're at it. I've added 3 hints here. A hex editor will help you a lot with this, so we're going to be using a hex editor. Try comparing the data of this image file to a sample bitmap file. Okay. And then how can I resize a bitmap image in its dibheader? So I've already gone and taken the liberty to download this file. We have it right here. Let's just go ahead and see what it looks like. Okay, so bitmap, it doesn't even load. Bitmap image has bogus header data. So we can go ahead and just, let's go ahead and use Vim, or we can actually use XXD on it to display the hex. But what I'm going to do is just run ahead on it, so that'll show like the first few parts of it. So we can go ahead and look here, and so this is where the file signature for a bitmap file would be. So we see it's 004D in here. So what I'm gonna do is just look up bitmap file header and compare it to what I have right here. So the dib header, bitmap information header field used to identify the bitmap and dib file is 424D in hexadecimal. So that does not line up with what we have. So the way I'm gonna edit this is in Vim. So I'm gonna use Vim image.bitmap. And then what I'm going to do is use semicolon, and then it's this xxd, I believe. Oh no, it's okay, hold on. It's percent exclamation point xxd. And this will show me the hex. So what I'm going to do is change this to, let's see what it was, is 42. So 42. Hopefully this will, oh no, I did not mean to do that. Hopefully this will go ahead and fix the header. So let me just repeat this just to make sure we did change it. What the heck? Okay, that's weird. I'm gonna go ahead and just copy it here again. And let me run xxd on it again. Okay, so that's weird. It like just didn't work. So what I'm actually going to do is just use an online hex editor that actually shows you the 16-bit integer instead of just the hex. So you can use hex.it, and it will just do this for you. So let me see what directory I'm in. Okay, yeah, I'm in HackMHS, and then tunnel vision, and then bitmap image. So I'm going to be viewing this with an online hex editor instead of Vim. And so let's just go ahead and change this to, I believe it's 42. So 424D. Let's save as, and then I'm going to save it into this directory as test.bitmap. Now let's go ahead and see what test.bitmap looks like. Okay, so we get our image, but we only get a certain part of the image. So we want to zoom out. Like we're only looking at this lake right now, hence the name tunnel vision. So how are we going to be able to zoom out and see the rest of this? Well, in an image's bitmap file, or in an image's dib header, I'm sorry, in a bitmap's dib header, it will actually show the resolution of the image. So that is where this hint comes from. So it says, how can I resize a bitmap image in its dib header? So we can look up bitmap dib header, and we can just go ahead and look through it on Wikipedia. And let's see if it will show this to us. So at offset 0, it just shows the magic, what it is. And it shows us all this. Okay, none of this shows the resolution, but I want to find the resolution. Okay, here we go. The bitmap width in pixels is at offset 12, and at offset 14 is the bitmap height in pixels. So what I want to go ahead and do is just find that offset. So at 10, and then we go 2 over 1, 2, and then right here is where we can see the bitmap width, I believe. Is it width or height? Yeah, width in pixels. So an unsigned 16-bit. So we can see in 16-bit, this is our width in pixels. And we can verify that by running file on test.bitmap. Oh no, okay, it doesn't show. But if we, so the original width for this is 1000 pixels. And then if we go, let's see how many bytes it is over. So after we go from 12, here, then we can see the height. So the height right now is 361. So that would explain why it's rectangular right now, because the width is 1000, but the height is only 361. So we can actually change this 16-bit integer. Let's go ahead and just change this to 600 and see what happens. So I'm going to change that to 600, and then I'm going to save it as test.bitmap, or test2 actually, so we can compare it to the first one. Okay, so then let's look at test2. Okay, we're starting to see a significant more amount of the picture. So we're just editing where the file reads the width and height of the image in its dibheader. So right here, once again, it's the width, which is 1000, and right here is the height. So let's go ahead and change this to 1000 to make this a perfect square. And then I'm going to save this as test3.bitmap. And let's go ahead and look at test3. And there we go. We've successfully repaired the image file, and we got our flag. So I'm going to go ahead and put this at the bottom of my screen while I enter in this flag. And yeah, so this is actually how you solve this problem in Pico. I believe there was one other step you had to do in Pico. I don't actually remember. I remember solving it though, but this challenge was pretty fun to make. And only one person solved it. And that was to get 100% completion, so it was pretty cool. Anyways, go ahead and submit that, and there you go.